have the reaction for photosynthesis. Remember, the reactants come before the arrow. So this is what you start with. And the products come after the arrow. So this is what you end up with. So this is like before and after. And if we look at, we're starting with 6 water molecules. So this is a water molecule. Okay, we're going to say the white balloons are hydrogen, so they're the lightest element. And this is not to scale, obviously, because they would be smaller than the oxygen atom. But here we have, so oxygen's the pink balloon, oxygen atom, and hydrogens are white. So we have 1 molecule of water right here. We have 6 of these though. So we have another one, 2, 3, 4. So here we have, right here, we have 6 molecules of water. Woo! Give me an H, give me an H, give me an O. What do we have? Water. Give me an H, give me an H, give me an O. What do we have? Water. Here we have 6 molecules of water moving around. All right, so here we have 6 molecules of water. And then we're going to have 6 carbon dioxides. Okay, these are the carbon dioxide. So remember the oxygen's pink balloons, they're just kind of deflating a little here. Carbon's the black balloon. So CO2. We have 6 of these though. Here I only have 2 to demonstrate. And then we're gonna, in presence of light. So light coming from outside, obviously from the sun. And we're gonna produce oxygen. So what are we making? We're making 6 oxygens, 6 O2. And the most important is glucose. So really the purpose of photosynthesis is to make sugar, and sugar in the form of glucose, C6H12O6. That is the chemical formula for glucose. You should know that. Glucose is sugar. This is where you get your energy from. But where do the carbons in the sugar come from? Here they come from carbon dioxide in the air. So this is a chemical reaction because the before is different than the after. They're not the same. Before and after are not the same. They're chemically different. Carbon dioxide is not the same as glucose. But look what happened to the carbons, these black atoms then. The black atoms, in a chemical reaction, we have a rearrangement of the atoms. The chemistry is different. So, for example, in this reaction of photosynthesis, the carbon in glucose, which is made, so one of the products, the main product of photosynthesis is glucose, sugar. The carbon, though, comes from the carbon dioxide in the air. So the carbon, see the black atom is carbon. So the process here then involves some breaking of chemical bonds, because it's over here the carbon is no longer attached to O2. So right here we're going to break the bond. Bond is broken. Chemical bond is broken and a new one is formed. So carbon is going to form glucose. The oxygen produced in photosynthesis comes from water. So over here, we start with water. The oxygen, though, is chemically bonded to hydrogen. Over here, it is not. So we need to get oxygens. So the water is actually split. So we're going to split the water right here. This is water splitting. So now we have oxygen. And we're going to have another water splitting. We're going to split the water. And now, these two oxygen atoms come together, forming O2. Whoop. So now we're going to form a new bond, new chemical bond between the two oxygens. Now we have O2. This is what air that we breathe. We need this. But this comes from the water. Photosynthesis, most important reaction of life. Chemical reactions are all just a rearrangement of atoms to make new molecules, make new compounds. So we just take you're using the same atoms. You can't make up new atoms. So remember, law of conservation of matter states that matter cannot be created or destroyed. It's just simply transformed from one form to another. So we have the form of water and carbon dioxide. These are the reactants in photosynthesis. And with light, sunlight, it produces glucose, sugar, most important product, and also produces oxygen. So the oxygen that we breathe comes from the process of photosynthesis. But it's all about shuffling atoms. It's just like a deck of cards. If you think of a card deck, the reactants, each card is an atom. In a chemical reaction, we're shuffling the deck, and then we're dealing out new cards. Some chemical bonds are broken, new ones are formed, and in the end, you're producing something different than what you started with. So if we look at the reaction for photosynthesis, the main product is glucose. And glucose is a 6-carbon sugar. So this is, remember, the black balloons are carbons. So we have 6 carbons right here, lined up. So this is like the carbon backbone. This is a glucose, it's a carbon-based compound. And when you study organic chemistry, you're studying the chemistry that makes up living things. And there are really 4 main elements that make up living things, and one of them is carbon. It's also hydrogen, oxygen, and nitrogen. But carbon-based compounds are what you study when you study organic chemistry. So this just demonstrates the 6 carbons in glucose. Now each one of these carbons is bonded with a chemical bond. So there's a chemical bond holding these carbons together. And there's energy in that bond. There's energy there. The energy stored in there. So if we were to remove one of these carbons, it would release that energy.